Owing to the ongoing pandemic, several organizations have started to increasingly rely on collaborative platforms for professional communication. Discord's main advantage is that its base product is 100% free, easy to set up, and thus is attracting huge number of small and medium-scale organizations to choose this platform. Through our submission, we aim to provide an end-to-end solution that allows enterprises to integrate their Discord workspace with Sentinel. This is the architecture of our solution, where the first component is the data connector. We have created a Python-based bot using Discord APIs, which serves as a medium between Discord client and Log Analytics workspace. The bot is hosted on cloud through Replik and allows message, attachment, and audit data to be instantaneously transferred to the workspace for further analysis. For the bot to be integrated with Sentinel, the following have to be configured by the server admin. We have decoupled the attachment processing component from the bot in order to reduce the computation load on this bot server. Instead, an Azure function is used here to process attachment data, which uncompresses the files, logs the metadata in Log Analytics workspace, and stores the individual files in storage account. Attachment blobs uploaded to Azure storage account produce operation streaming logs which contain hashes related to the blob. These hashes are compared using Microsoft's threat intelligence to do hash reputation analysis looking for viruses, trojans, spyware, and ransomware. Whenever a match is found, an alert is triggered in Azure Security Center. To detect threats from the logs in Log Analytics workspace, we have configured analytic rules. Let me take you through one such analytic rule. I have a malicious URL handy with me, and I am currently sharing it as a message in one of the Discord channels. So we have an analytic rule configured here, which is set to trigger for every 5 minutes to check the data in the last 5 minutes. So if I go to the query, we see that we are relying on a third-party threat intelligence feed, which periodically increases the dangerous domains and IPs list. We are querying this data to see if the URL that is shared by the users is matching with them and triggering an incident based on that. For the analytic rule that has been triggered, we see that the URL that we have uploaded has been deleted, and also we see that a response has been triggered in the form of a Discord alert as well as an email. This email has details related to the alert name, the description, and who has exactly shared the malicious URL, and also the URL is listed here for further investigation. I'm next going to illustrate how a solution is going to protect Discord members from malicious attachments. Discord's inbuilt AV is very limited in terms of protection against malware, and I can illustrate that using a simple example here. Let's say I upload a dummy malware file, which is a icar.txt file. Discord's inbuilt security immediately identifies that and deletes it for me. But if the same file is zipped and uploaded again, this bypasses the Discord's default security. So now in our current model, we have uploaded a zip file containing the virus, and let us see how this is detected in the current solution that we have. So we have previously uploaded a malicious attachment in Azure Alerts channel, and this has been sent for processing by our solution. We see that we got a high alert triggered, and if we go into the details, we can see who has uploaded this file and at what time this was uploaded, along with the channel this was uploaded to. Although we have uploaded a zip file, our solution recursively unzips and looks for malware in each of the constituent files. So we can see icar.txt here instead of the icar.zip. Apart from this, when files are stored in Discord, they are stored within the Discord's content delivery network, and they can be accessed using the hard-coded CDN URL. And this can be accessed by simply going through the browser without any authentication, and any person can access the file within it. For attackers, one of the key challenges associated with malware delivery is making sure that their files and domains don't get taken down or blocked. Therefore, by leveraging Discord CDN, they are moving several such hurdles since these files are uploaded and linked via CDN URL. Our solution goes a step further by not only identifying threats in attachments, but also tracks down the malicious contents disguised as a CDN URL. So here I am pasting the CDN URL containing the malicious attachment. And let's see how our system processes this URL, where the actual malicious file is disguised in the form of the URL. Attackers are also using uncommon compression algorithms to obfuscate the malicious content. We are preventing this by allowing Discord admin to blacklist extensions and only allow zip formatted attachments to be uploaded. We see that previously the CDN URL which we upload turns out to be a malicious content, and that is the reason the message was deleted, and also we have received an Azure alert. We can see that who has uploaded this file, the time when it's generated, and the channel and the corresponding file name which was uploaded. I also receive an email alert indicating the same. From here, I can find a link to the incident where I can navigate to find more details. So this is my incident dashboard where I'm able to get the details related to the particular incident. And if I go to the entities details, we can map and analyze the incident by examining the activity of that particular user with the help of these entities. Here I'm also able to see the similar alerts that have been triggered by this particular user. Now, to find out more details regarding the malicious attachment that has been uploaded and also the suspicious user, we can navigate to hunting queries to find out more details. So here we have a hunting query defined for monitoring the members' activity. And if I go to the view results, here I am provided an option to give the username of the user that I am interested in, and once this query is executed, we get important details such as what are the distinct audit operations that he is performing, and in this case he is performing critical operations like granting admin privileges to roles and users, etc. What is the message count, what is the number of URLs that he shared, the attachment count, and also the channels that he is frequently using. Moving on to another hunting query that we have, this will give us details about what kind of malicious file that has been detected over the last week. Let me now take you through the automation process that was executed by the incident playbook. So here are a list of playbooks, and the one currently we are interested is the malware response playbook. This is a common playbook which has the condition for the case of malware URL and also the malware attachment. We can see that we defined an easy to understand flowchart where based on the different conditions we are executing the logic to delete the message in the case of detection of a malware, and also triggering an email as well as the Discord alert. Moving on to workbooks, we have plotted several graphs and charts illustrating the trends in the Discord audit data. We have time and user parameters defined which allow us to plot the graphs based on these inputs. Here I am able to see the messages shared by this particular user in multiple channels, and also the total number of messages, URLs, and attachments sent in each channels by all the users. We then have a bar chart that indicates the count of various file types shared in the channels. The plots below show the count of attachments shared by users and indicate a possible threat level based on the user sharing pattern. We can see a similar analysis done for URLs too. We then have plots related to the upload patterns of users. Apart from that, we are also tracking the different kinds of domains that are shared as messages. Moving on to the next section, audit operations, we see that various kinds of audit operations performed in Discord channel along with their count and trend. Next, we see few plots related to attachments. We can see the number of forwards happening from each channel in an easy to visualize bar graphs. This is critical as admin can monitor how frequently data within a channel is being shared outside these channels. We then see attachment upload trend per day and per week. In the last section, we have plots related to the security alerts triggered by severity and product along with the trends observed. We then have 13 analytic rules configured which search for specific events and alert the Discord admin when the thresholds or conditions are met. We have already seen detect malware and malicious URL analytic rules in action previously. Similarly, whenever admin privileges are granted or revoked to a role or user, a high severity incident is created that allows Discord admin to track these critical operations. Further, we create custom queries to track attachment forwards and also trigger incidents whenever a newly created bot or user joins our server. This is to keep track of their activity before they start sharing any malicious content. Let's now see two more analytic rules in action. In communication platforms, a lot of times we observe that users share credentials in messages, which is highly risky. Our analytic rule uses advanced regex-based queries to filter out such messages and creates an alert. We see that we have defined multiple regex expressions which match various kinds of secret credentials that may be potentially shared in the form of messages. To demonstrate, let me copy a JWT token which is considered highly secure. and I'm pasting that in one of my channel. And let's wait for the analytic rule to run and create an alert for this. After 5 minutes, we see that an alert has been triggered based on the analytic rule that we have triggered. So we can see important details such as who has sent this message and at what time this was generated, along with the channel and also the sensitive information that was posted. Based on this information, admin can make the decision to delete the following message if he requires. The next analytic rule, new user sharing links, checks if a newly joined member is sharing links within a time window. I have a test user here who has joined the server few minutes ago, and now I'm logging in as this user, and if I start sharing URLs, we should see a medium level incident created. We see that 2 new incidents have been created. One incident is talking about the new user sharing links, and we could see that this is triggered because the newly created user has started sharing the links within the given time window. And also, the link that has been shared by this particular user has turned out to be malicious. So this in turn triggered another analytic rule, which is talking about the malicious nature of this URL. And as a response, it has sent us an alert in Discord, where we can find further details related to the URL shared and who has uploaded, and in the channel that it is uploaded to and the time that is generated. And also we can notice that this URL is no longer available. It is instantaneously deleted as soon as it has been found to be malicious. Once Sentinel solution has been deployed, it's extremely important to monitor the resource usage. We have created a dedicated workbook that facilitates Discord admin to find the analysis of all the resource usage at one place. We first plotted the log analytics workspace usage, which is the primary location where Discord data is ingested. The below graphs define the trend observed in the messages and audit operations performed in Discord. We then move on to the storage block, where we can see rich illustrations on the various kind of blobs operations performed, along with the request count, trend, execution time, etc. Also, below are the set of standard graphs which provide information related to the blob storage, such as capacity, availability, transactions, latency, etc. Our solution makes use of Azure Functions to decompress the attachment data. Through the plots here, we can monitor the execution trend of the function, the status of the function, and also the time taken to execute.